Hey everyone, welcome back and let's write some more neat code today. So today let's solve min stack. So this is a pretty good design problem and the description is pretty simple. So our job is to design a stack class that supports 4 operations. Obviously, we want to push onto the stack, we want to be able to pop from the stack, and we want to be able to get the top value on the stack. And last but not least, the fourth one, this is the part that's going to be tricky. We want to be able to retrieve the minimum element in constant time. So we want to be able to do all 4 of these operations in constant time. Now, if you are familiar with a stack data structure, you know that by default, a stack will be able to support adding a value, popping a value, and getting the top value, all 3 of those in O of 1 time. Now, I'm not going to go into the details of how to actually implement a stack. You can implement it with a linked list or you can do it with an array. In this problem, we're basically just going to use the built-in data structure that is pretty much implemented as a stack. But the main part of this problem is being able to do this last operation, getting the minimum value from the stack in O of 1 time, right? Because by default, a stack doesn't support this operation. Now, a stack, let's say we're implementing it with an array. So let's say this is our stack. And let's say we do a few operations. Let's just look at this example, right? We push a -2. We push it, let's say, to the bottom of the stack. We push another value, a 0. We push another value, -3. And now, so we did 3 push operations. Now we want to do a get min. So how exactly are we going to be able to get the minimum here? Well, a naive way would be just look at every single value, -3, 0, -2. So we can look through the entire stack. That's going to be O of n time to get the minimum. So at least we have a baseline. At least we know how to do it in O of n time. That's not too bad, but how can we do better? How can we actually get it to be O of 1? And if you want to try to figure it out yourself, I recommend taking a look at this hint that LeetCode actually provides. They say consider each value in the stack having a corresponding minimum value. Think about that for a second. So let's go back to the basics when we were adding 3 values. So when we first added a value, we added a -2. So what's the minimum at this point in our stack? When we only had 1 value, the minimum at that point was -2, right? When we added another value, we added a 0. What was the minimum at this point? When we added the 0, did this replace our current minimum -2? No, it did not. So in other words, we can leave our minimum as it is. But that's not always going to work. Having a single value maintaining the minimum isn't always going to work because, for example, let's say we added another -2. Okay, our minimum stays the exact same, -2, right? Now, what if we pop this -2? Okay, we pop that -2. Now, how do we know what's the new minimum? Is the minimum going to stay -2 or is it going to be 0? Well, of course, we know it's going to stay as -2, but how can we do that? So a good workaround is for each position, write down what's the minimum at this point. So when we pop, then we know, okay, this is going to be the new minimum. So let's say at this point, the minimum stays -2. And we added a third value. Remember, we added a -3. So now what's the new minimum? We can compute it in O of 1 time by just comparing this new value we added and comparing the current minimum. Obviously, -3 is smaller, so at this point in our stack, the minimum value is -3. If we were to pop this -3, then the new minimum would be a -2, right? This would be the top of our stack. This would be the minimum so far. So what you might be noticing is on this right-hand side, I'm actually defining another stack, right? We have 2 stacks. One stack is telling us the values that we've added so far in the order that we added them. The other stack is telling us what's the minimum value that we have added so far in each position of the stack. So if we add a value, we'll be inserting into both stacks. If we pop a value, we'll be popping from both stacks. When we get the top value of our stack, right, because remember, that's an operation, the top value, we're going to be looking at the first stack. We're just going to say, okay, this is the most recently added value in the stack. When we do the get min operation, we're going to look at the top of our minimum stack, get that in O of one time, right? We just have to get one value, so we can do it in O of one time. Don't have to pop anything. We just have to take a look at our second stack. So that is the main idea. It's a little tricky to actually come up with this, but once you do, it's very simple. So now let's actually jump into the code. Okay, so now let's get into the coding portion. So we know that we have to support 4 operations, and in our constructor, the first thing we're going to do is, since we know we're going to have 2 stacks, let's define those stacks first of all. And like I said, I'm going to be implementing this with an array, or at least an array list. If you are using Java, this is not just an ordinary array. We can append, pop from it. It's basically Python's implementation of a regular stack. We're going to have a second array, which is going to be the min stack. And initially they're going to be empty. So the simple thing to do is push, right? That's the first operation. So on our first stack, it's always going to be easy, right? We're always going to take the input value and append it to the first stack. Now with the second stack, we need to know for the second stack, if there's already a value inserted in the minimum stack, then we're going to take the minimum of the input value and the minimum value, or at least the value at the top of our min stack, and take the minimum of those two and then append that value to the min stack. So let's update our value first of all. Let's set it equal to the minimum of itself and the minimum of the top of our min stack. So let's say self.min stack at -1. At least that's how you do it in Python. But we know that this min stack actually could be non-empty. So we're going to only do this if our self.min stack is non-empty. Otherwise, let's just take the minimum of val and val. So this might be a little complicated. I probably could have just done an if-else statement, but in Python, I feel like this is a little bit cleaner. So we're just taking the minimum of value and the top of our stack if the stack is non-empty. If it is empty, we're just taking the minimum of val and val, because if the stack is empty, then of course we're just going to take the min stack and append the value to it. Right, so when we append this value, it should be the minimum of the input value and the minimum of the top of the min stack. So that's all for our push function. Now let's do the pop function. We don't have to return anything. All we have to do is pop from our stack, but since we have 2 stacks, we're going to have to pop from both of these stacks. So popping from the first stack and popping from the minimum stack. So that definitely takes care of everything for us. It feels like cheating since we're pretty much using the built-in functions. And to get the top value of the stack, we are going to take from the top of the first stack, right? By top, we want to get the last value that was inserted, and this is always going to be called when our stack is non-empty, so we don't have to take care of any edge cases. The last one, get min, is going to be returning from the top of the min stack, right? Because we want the minimum value.